Mr. Clelland here, Clelland Maths. So we're going to be looking today at how do we solve simple algebraic equations like x adds 7 equals 13. Now, don't be tempted to rush in here and just guess the number. All the examples I'm going to do today are going to give whole number answers, or most of them are, but that's not the point. The point is to develop our algebraic skills. Let's first of all look at something else before we even do that, a skill we'll need, and it's called the additive inverse. Additive inverse, basically making zero. I'll do this with an example animated wise. So let's say I took a number 1. If I want to make 0, obviously I'm going to have to take away 1, right? That should be obvious. So I can reverse that, 1 and minus 1, and that would make 0. It would disappear, right? I could take any number and do that. I could take a number 7 and take the opposite of 7, which is negative 7. So 7 and negative 7 make 0. So whenever I want to make 0, I just need to take the opposite of it. So if it's positive, I need to take the negative. If it's negative, I need to take the positive. But I can do that with algebra as well. If I had x, the opposite of x would just be negative x. So x and negative x would also make 0. And I can do that with any number of x's. I can take it 7x. The opposite of 7x would be negative 7x, which putting together would make 0, right? So in other words, taking any number, let's say plus 6, if I want to make 0, I would need a negative 6, and that would give me 0. Or if I had a negative 11, if I wanted to make 0, I would have plus 11, that would make 0. And similarly, with algebraic expressions, if I had any expression x, the opposite of x would be negative x to make 0, or any expression, say 5x, the opposite of that would be negative 5x, which would also make 0. Now you're probably asking yourself, what's the point of this? Well, that's exactly how we're going to solve algebraic equations to start with. We're going to be looking at balancing both sides, and we're going to be looking at what do we need to do to make 0 when we're trying to get rid of a number, and on one side to just leave the algebraic expression. So let's go back to the example that we had to start with. How do we solve x adds 7 equals 13? Well, if we think of it as little tiles like we just had before, you would have an x tile. And I'll probably put it plus x so we're clear that that's a positive. We've got a plus 7 tile on this side. And then on the other side, I'll draw a line, we've got plus 13. So now the goal at the end is just to have x on one side. So I'll leave the x as it is. So I want to get rid of this plus 7, so I'll just try and make 0. 7 and minus 7 is 0, and I have to do the same to both sides. So the 7 and minus 7 cancel to make 0, so that leaves on the left hand side just a positive x tile. And it leaves on this side, that's plus 13 take away 7, which is plus 6. So we've now solved the equation. The answer is x equals 6. And we'll build this skill up as we go. So let's do a few more examples. So example 2 says solve x, take away 5 equals 12. So we can think of this in the same way. I'll use blue for positive, so plus x, and I'll use red for negatives. I've got negative 5. Line down the middle for the equals. And I've got a plus 12. So remember, the goal is always to get x on its own. So we need the opposite of minus 5. So we need to add 5 to this side. 5 and minus 5 is 0. So we add 5 to the other side to be fair. We can now imagine that it's just cancelling. We're gone. So that's leaving me with plus x on this side. And it leaves me with, well, 12 plus 5, 17, plus 17. So the answer is x equals 17. Let's do another example. So example 3 says solve, and we've now got it written in a different way. Negative 14 equals 8 add x. Looks a little bit funky, but using the same sort of method, we'll start here. I've got a negative 14 red tile. There's my line for the equals. 8, well, that's plus 8. X, that's plus x. Doesn't matter that the x is over here on the right, we'll just keep it there. We just want x on its own, so we need to get rid of this plus 8. The opposite of plus 8 is negative 8, so underneath that I can write minus 8. And I'm doing the same to both sides, so I'm taking away 8 here as well. So now these are cancelled. That's gone. 8 and minus 8 is nothing. So looking at the left hand side first, I've got negative 14 take away 8. Be careful with your sums here. That makes negative 22. And on the right hand side I've got plus x. So as soon as you've got that, just a plus x, we now know the answer is just x equals whatever's there, minus 22. Just like that. So example 4 says solve 7 take away x equals 8. So on this side I've got a plus 7 and I've got a negative x, and on the other side you've got a plus 8. Now this one's a little bit stranger because we've got a negative x. And we always want to want a plus x, remember, at the end. So we're going to have to do the opposite of negative x first. So the opposite of negative x, as we've seen before, is plus x. And we always do the same to both sides. So that will get rid of this side. So that leaves on that side your plus 7 tile. On the other side we've got a plus 8 tile. And we've added an x. And now it looks like it looked before, so we can start doing what we did before by taking away the number which is next to the x. So we've got plus 8, so we can do the opposite of plus 8 to get 0, which is negative 8. Negative 8 on the other side. So that leaves us with, I'll keep the same colour actually, so 7 take away 8. 7 take away 7 is 0, an extra 1 makes negative 1. And on the left hand side, we're gone, so I've just got a plus x. So in this case, x equals negative 1. Okay, here's some work for you to try. So solve to find x. Use the method I've just shown you. You can pause the video here to complete your task. And here is all the answers to the ones we've just done. Thank you very much. I hope that was a helpful video for you on solving basic algebra equations. Take care and stay safe.